Hey, today we're talking about getting character and string input from streams in C, and the odd case where you actually want to put something back on a stream. It gets a little weird, but let's do it. Hey everybody, today's video is inspired by a question from Bill, who's one of the channel's Patreon supporters. And before I get too far into it, I just want to say a huge thank you to all of you who support this channel on Patreon by subscribing, by liking, by sharing these videos with your friends. And I also want to thank NextPCB. They are a printed circuit board manufacturer who has been a huge supporter of this channel. If you're interested in embedded systems and making your own PCBs, there are links in the description. I hope you'll show them some love. But anyway, let's get back to Bill's question. See, he was trying to replicate the behavior that he was seeing in the Getstring function that they use in Harvard's CS50 course. And he asked if I could make a video on getting string information from a stream like stdin or a file. So today I thought I would take a look at this because it's amazing. It seems like a really simple thing, but sometimes it gives students more trouble than they expect. It also gives us an opportunity to look at resizing arrays and some of the consequences of not fully standardizing things like line endings. Now, before we get too far into it, there are a lot of standard ways to get input from a file or from stdin. You can use fgetc or fscanf, or you can use fread, which is especially useful when you're reading in binary data. Both fscanf and fread probably deserve their own video. Today, we're going to look at getstring, which is not part of any standard that I'm aware of, but it's a function that's used in Harvard's CS50 course, which I know actually a lot of those that follow this channel have taken. And I think it provides an interesting alternative to fgetc that is going to be kind of interesting to play around with. So just to make sure we're all on the same page, getstring is a lot like fgetc in that it takes a stream, one of those opaque file pointer types that we use either for files or pipes like stdin, and it reads a line from it, basically reading until it reaches the end of the line or the end of the file or stream, and it returns that text to the user. Now, one big difference between fgetc and getstring is that with fgetc, we provide it with a buffer and a maximum length, and it fills that buffer up to the maximum number of characters. On the other hand, getstring allocates the memory on the heap and just returns a pointer to that memory once the line is finished. And so because that memory is allocated on the heap, we need to free that memory later. Now, to make just a few things clear up front, fgetc is going to be faster than getstring. And that is because it doesn't have to spend any time allocating memory or resizing arrays. With fgetc, you've already done that. You've already allocated the space. You've already set the size, and it just runs through. Now, getstring, on the other hand, is a little more convenient because I don't have to know what size my input's going to be. I can just take any size I want, and it's just going to work. Because getstring is going to resize this string, this buffer, as needed. Basically, I just keep adding characters to it and it just keeps growing. And so today I want to look at how we implement getstring, and we're going to start with a really simple implementation, and then we're going to try to see if we can make it a little bit faster. So if you stick with us to the end of the video, we're going to look at basically comparing some different options. But first things first, let's jump into the code. Okay, so just to start out, let's just start with main. Because we just want to think a little bit about how we're going to use this thing. So let's start up, we're going to write our main function, and this main function is going to test out our getstring. And so we could just use a pipe like stdin or a file for this. For today's example, I think I'm going to use a file because it's going to help with the timing tests that I'm going to do later on. Because I really don't want to be measuring my typing speed. I want to measure the code and how fast it runs. So first of all, let's just create one of these file pointers. We'll call it fin. It's our input file. And we're going to call fopen. And for now, just for starters, let's just read the source code for the program. Later on, I'm going to change this. I've got this test input, which is a much bigger file, but just at first, we just want to see if this works. So let's start by opening it in read mode. So this is going to help us see if our whole program works. And then later on, we're going to look at testinput.txt, which is like 75 megabytes of text input. And one thing that you are going to learn that I just wanted to point out up front is that when you're timing things, one thing that is really useful to keep in mind is that accurately timing super fast or super short things is really tricky. But if you have something really short that you want to measure, but you don't want to get into all the details of getting it right, you can always call that function or run that code many, many times, and then it gets easier to measure because it's taking more time, and you can use coarser grained timing measurements to see the differences that you actually want to see. Okay, so now let's define a few variables here. The first is, let's come up here and grab our string. So we're going to have, let's call this str. That's the thing that's going to come back. And I also want to create an integer that's going to keep track of line numbers because I actually want to do something with the data I'm breathing in. And that's just gonna keep the compiler from doing anything really clever like optimizing stuff out. I don't really want any of that. So in this example, what I'm gonna do is I'm gonna read in the input and I'm just gonna stick line numbers on the front. And then we're gonna print that final output to standard out. So now down here, and this is really common in a lot of programs like this, we're just gonna have a while loop that we're gonna stick in here. And we're going to call Getstring. Now remember, that's going to read in a line. It's gonna basically go until it hits the end of the stream or until it hits an end of line character. We're gonna pass in our stream, and then we're gonna keep going until we return null. So at that point, we know we're done. Because Getstring is going to return null only once we've reached the end of the stream. Okay, so now we want to come in here and just print out our output. We're gonna print out the line number, and we're gonna print out the line itself. And let's not forget our new line here. So let's put our line num, let's increment it while we're at it, and we'll print out our string. Okay, so whatever we got from the file, we're gonna print out. And then down below, we're just gonna call free. Remember that Getstring is going to actually allocate this on the heap, so we have to make sure that we free it when we're done with it. Okay, so this is our main function. It's pretty simple, but this is all we're gonna need to test out our Getstring, make sure it works. And of course, I could try to compile it, but I don't have a Getstring function yet, so it's not gonna work. So let's go ahead and write one. Okay, so up here at the top, we're going to create our Getstring function. It's gonna return a character pointer, and it's gonna be called Getstring. And then we're going to pass in a stream, a pointer to this file struct. Okay, now I'm also going to declare a couple of variables. Let's have a bytes variable. This is going to keep track of how many bytes I've actually received from the stream. And I'm going to have a buffer that's going to be a character pointer. This is the thing that we're eventually going to return. Initially, we'll just start it out as null. And then we also need a character, and this is just going to be each character. We're going to read in one character at a time. And so here I just want to store it somewhere. So we're going to call this C, and we're going to read this in a while loop. In that while loop, I'm going to read C. I'm going to get a new character using fgetc from my stream. Now you may be familiar with this function. This function just reads a single character, which is great. And we could just use that, but that's not usually what people want. That's actually why we're making this getString function, is we rarely just want to read one character. Instead, people usually want to get a whole string or a whole line, some chunk of text from this thing. And so we're going to loop through and we're going to grab it each time. And we're going to loop until we reach EOF. That's going to be the end of the file, or the end of our stream. But we also want to stop if we happen to run into the case where C is equal to a carriage return. Need to add that. Okay, yeah, we need test equivalence. And also if we run into a line feed character. Okay, so either of these are going to mark the end of a line. And this is something that I just want to pause about because, why are we checking both? And that is simply because people didn't standardize how text works back in the day. So how do we mark the end of a line? Well, Unix uses a new line character. This is sometimes called a line feed character. DOS and later Windows use a carriage return and a line feed. So this is like /r/n. And until version 9, macOS just used a carriage return. Fortunately, they came to their senses and just switched to the Unix model, but the point is this ambiguity makes things messy. So I want to write my code so it hopefully works on any machine out there, so I have to watch for both of these characters, which is of course a pain, but it's what we're going to do. So until we can get the world to just stop using carriage returns, which would be great, we're going to have to deal with this mess. And you're going to see this ambiguity crop up again in a minute, but for now, let's just move forward and look at what goes on inside this loop. So once we're in the loop, we know that we have a valid character. We know that it's not the end of the line and it's not the end of the stream. So we have some character, we're going to want to print it out. And so here we're going to increment the number of bytes that we have. That's just going to keep track of how many we've received so far. And now we know that our buffer is not big enough. And so what we're going to do is we're going to use realloc to make our buffer bigger. Okay, so I'm just going to reallocate it to be bytes plus 1 characters long. Now, notice that I'm using bytes plus 1 to leave room for the null character that needs to come at the end of my string. Remember, we're in C, we need the null character there. And yes, I know some of you are going to look at this and say, this is not that efficient. You're calling realloc a lot of times. We're going to come back to that later, but one thing at a time, folks. This is how I'm going to do it this first time through. And of course, there's always the possibility, it doesn't happen very often, but there's always the possibility that realloc failed. And so we're going to check to see if it's null. If it is, then we're just going to return null. That means we basically couldn't get memory because realloc wouldn't give it to us. So sorry program, no string for you. But otherwise, then we just come down here and we're just going to add our new character to our buffer. Okay, so it's going to go into bytes minus 1. Remember, I'm using bytes minus 1 here because I've already incremented my number of bytes, so I got to put it back 1. And that's really all we need inside this loop right here, and that's just going to keep going and adding characters and growing our buffer until we reach the end, which is exactly what I wanted it to do. So now we've got this loop here. Now what's left? Well, the first thing we need to do once we're out of here is address this whole line ending issue that we talked about earlier. See, it presents us with a little issue. We know we've seen either an end of file or a carriage return or a line feed, and we could just move on, except Windows had to introduce to the world the carriage return line feed combination. So if I saw a carriage return, there might be a line feed character still sitting there and I want to remove it, or the next time getString is called, it's just going to see that line feed and return an empty string, which is very much not what I want to have happen. Okay, so what I'm going to do here is I'm going to say if we saw a carriage return. So if C is equivalent to /R. So if this happened, then that's great. Let's just read one more character. Okay, so we're going to read one more character from our stream. Now, if it actually is the line feed that we were worried about, then great. That just means we got it out of the way, it's out of the stream, we've removed it. But what do we do if we're not on a Windows machine, or this file wasn't created on a Windows machine, and we actually just removed the first character of the next line? So, oops, that's a problem. We definitely don't want that to happen. And there is a convenient way we can solve this problem. Thanks to Microsoft for spreading this nonsense all over the computing world. We actually have a function for handling this, and that is ungetc. Yes, you heard me right. Ungetc, believe it or not, puts a character back onto your stream. So what it's going to do, I'm going to be able to say if C is not equal to /n, so it's not what I was looking for, meaning that it's something else, it's the beginning of the next line, then what I can do is say, oops, that's not what I meant to do. I actually want to put it back on, so I can just say ungetc and put character C back on my stream. And this function, interestingly enough, is only guaranteed to work for a single character. It's not like you can put all the works of Shakespeare back in standard in. It only is guaranteed to work with one character. Now, why? Because the whole existence of this function, I mean, the entire reason we have ungetc is to compensate for nonsensical line endings. Okay, there might be other legitimate uses. This is just the only one that I've ever come across. So I'm pretty sure it's the only reason it exists. But anyway, the point is ungetc is there, it's available, and we're gonna use it right here to fix this problem. So if I don't see a new line, I'm going to just stick that character that I read back onto my stream. And so now we know that we have cleared off our trailing line feed if it was there. And so now we really need to just get into the end game. Now we know we have our string and we know that we have cleaned up the stream. So now we just got to finish things up. The first thing we're going to check is if our buff is null. Okay, so if it is, then we know we didn't read any characters. So there's a couple different cases. Okay, so if our character happened to be EOF, that means we are at the end of the stream. That means we have no data and we're at the end of the stream. So in this case, what I'm going to do is just return null. Okay, that means we are done. There is nothing else to read. But if we didn't get EOF, that just means we have an empty line and there might actually be more to read. In fact, there probably is more to read. And so I want my users to be able to tell the difference. So what I'm going to do here is I'm just going to say buff equals malloc1. So what I'm going to do is I'm just going to allocate space for one character. That's going to be the null character. And that's going to give my user something that is printable so they can actually print it out and they'll be able to tell the difference between the end of the stream and just an empty line. Okay, so now the last thing we need to do, we come down here and we just need to null terminate our string. So we're going to null terminate it. And we'll do that by just saying buff fights equals 0. Okay, so that just sets the last character in our buffer to be 0, which tells it the string is done. Okay, so we do that. And then down here, we're just going to return our buff. We're going to return the string that we got. And that's our function, at least the first run of the function. I said it was simple. It's a little bit long, but it's pretty straightforward. Okay. So now let's go down and see if it actually works. We're going to make, and it looks like I mistyped and said fgets, and I meant fgetc. Sorry about that. Okay, so we compile it. Now we can run it. What? And oops, one mistake. I realized I put equivalence up here where I needed not equals. We're trying to avoid the end lines or go until as long as it's not equal to these things. Sorry about that. And now if we come down and compile, and if we run our example, you can see, sure enough, it works. It printed out my source for the file, no problem, my source code for the program, and we have the line numbers down the left side. So it's working just fine. No problem. So that's great, but we're not done. Like I mentioned earlier, I did some things in here that were a bit inefficient, so I want to see if we can improve those a little bit. But the first thing I'm going to do is to go up here and to go in and down into main and actually change the file that we're reading from. We're going to use test input.txt. Just this is a bigger input file, so we're going to be able to see things a little clearer. And if we compile it, and now I want to time it. I want to run my example program, and we're just going to pipe the output to out.txt. Because I don't want a million lines of text going to standard out, that's going to slow things down, and I really want to focus on the speed of my function that I just created. So if we run this, then we'll just wait a second and you'll be able to see how long it takes. And okay, so that's the time we're racing against. About 5.82 seconds is the total amount of time it took to process this 75 megabyte file. And this isn't terribly slow. I mean, we could live with this, but if we come back up here in our code, if we come back up here, there are some obvious places that we could improve on, particularly up here where I resize the array. Like up here, I'm basically resizing the array after every character. So that's a lot of function calls for every single character, meaning that without fail, every time I read a character, I'm going to call realloc. I'm going to have to increase the size of the buffer. That may involve copying, and that really doesn't need to be happening here. So I want to change this up a bit, but I want to leave the original in place just so that you can see both versions when I post the source code. So I'm going to copy this. I'm just going to make two different versions. We'll call this one getstring2. And now down here in my getstring2 function, I'm going to change up a couple of things. The first is I'm going to make a new integer. I'm going to call it capacity. And we're going to start out at some round number like 50, okay? And actually, let's move this down below because I'm going to use capacity. And instead of starting this out at null, I am going to assume that I'm usually going to read something. Okay, just about every time I call this function, there's going to be some information coming from the stream most of the time. And if you look at it, really the only time that we're not going to need to make a malloc call is when we receive end of file, when we get to the end of the stream. And so this is pretty safe to just say right up here, we're going to malloc capacity. Okay, so I'm going to just pre-allocate 50 bytes at the very beginning of my function. And that way I start with a capacity of 50, and you could allocate less or more. It probably doesn't matter that much, and it depends a little bit on the input that you're going to be bringing in as far as what the right number is. But then down in our while loop, now we can just check. Every time we increment it, we can basically just say, okay, if bytes plus 1 is greater than or equal to capacity. So this basically means if I've reached my capacity, then I'm going to resize. And let's get our indentation right. So instead of resizing the buffer every character, now what I'm doing in here is resizing it, and not to bytes plus 1. What we're going to do is we're still going to go with capacity, but I'm going to take capacity and increase it. In this case, I'm just going to double it every time. That way, if you end up with some really long ones, it's okay. You won't have to reallocate nearly as often. And so this really is just going to dramatically reduce the number of realloc calls that I'm going to make. So let's see if that helps. Let's go down here into my main function, and instead now we're going to call getstring2. Let's compile it, see if okay, no mistakes. That's great. And now let's just run it like we did before, and we'll see how long it takes. Hopefully it's a little bit faster. I expect it will be. What? Okay, that wasn't what I expected. Let's see what I just did wrong. Oh. Now, one other thing I just noticed is there's one more thing I need to change, and that is that I was determining when we got to the end because we got this buff equals null business. Okay, that's going to be a little bit of a problem now because obviously buff is never going to be null. We just malloc it from the very beginning. So instead what we're going to do is to say if bytes equals 0, meaning we didn't get anything, we're going to use that instead. Now we can return null, except before we return null, we need to make sure that we free our buffer. Since we're basically giving back a null pointer, we got to make sure we clean up our memory. Okay, now let's compile it. Let's time it, see how this works. Hopefully it should work this time. Okay, so there it goes. Now, just so that you can, just for comparison's sake, I'll come up here, we'll put it back and rerun the old version. And I mean, you could of course rewind the video, but here you're going to see that it does take considerably less time. And of course we can't remove all of it. You know, there's some things we're just not going to be able to remove, like the actual time it takes to read in the data from the file. but we did remove some extra function calls, and you can see that makes a considerable difference. So the downside is, of course, that we are now allocating a little more memory than we need. That's usually okay. I mean, here in the computing field, we often waste a little space for speed. That's basically the underlying principle, or one of the main principles behind how modern virtual memory works. And you see this in file systems and a lot of other scenarios. So I hope that's helpful. I hope it gives you some insight into how functions like getString work, also insight into how to dynamically resize arrays, and now you even know how to stick a character back in standard in, or any stream for that matter. So lots of good stuff here. Like the video if it was helpful. Subscribe if you don't want to miss my next video. Support the channel in the many ways that you currently are. And until the next video, I'll see you later. Happy coding.